Welcome back, everybody, and today we're going to be in chapter 12, which looks at experimentation. And experimentation is unique in as much as you can control the variables and the environment a lot of times in regards to the study and research that you're going to do. There's a lot of issues involved with experimentation, so let's go ahead today and begin as we take a look at chapter 12 and experimental research. Okay, everybody, welcome back, and today we're going to be in chapter 12, which deals with experimental research. Now, unlike surveys and observations, experimental research allows you to control the environment to a large extent and control the conditions under which you will do your research. So let's take a look today at what we mean by experimental research. Some of the terms you need to understand before we begin. First term is subject. Now, subjects are the ones who are being studied in your experiment. If you remember, we called those who responded to interviews and questionnaires and surveys as respondents. They're responding to you. Subjects are those who are going to be a part of the experiment, either those who will be in the experimental group or those who will be in the control group, and we'll talk about those here in a little bit. Along with this, you have independent variables, and then you have the experimental conditions, and that's where you manipulate the variable, whatever that manipulation may be. That's the experiment itself. Blocking variables, and these are variables that are included in the statistical analysis as a way of controlling or accounting for variance due to that variable. Now, let me give you the example that the textbook gives, and I think it's going to be easiest if we just use the textbook as the criteria or the standard for our examples in this chapter. Now, the textbook talks about how a study was done with employees at a certain company, and they wanted to study self-efficacy, which is the study of self-esteem and how people regarded themselves. Self-esteem is important today as we look at motivation and productivity. If a person has a low self-esteem or low confidence, chances are they're going to be low in motivation and low in productivity. But anyway, what we're looking at here is the way of determining if positive feedback has an effect on the employees. And they divided up between those who were veterans and those who were brand new, and they used the control of no feedback, which means that there were a group that did not get any positive feedback at all. They got no feedback, period. And then they used another group who were given feedback, positive feedback, and they measured the results. Now, there are some cases, as in the case of blocking variables, that you really can't control, but they are part of the way a variable is influenced. For instance, and the textbook uses sex. You can't control that, but sex could have an influence on people's self-efficacy as to whether or not they were given feedback or not given feedback, whether they were a long-term employee or a brand new employee. So, for instance, they may say that females may be more sensitive to positive feedback and thus their self-efficacy may increase, or males. I don't want to bias it in any way, but that would be a blocking variable, something that will affect that outcome, but you can't control it. Now, creating an experiment. We have the idea here of the main effect, and that's the experimental difference in dependent variables. The variable means between the different levels of any single experimental variable. And the book here talks about there could be main effects for the outcome of this study between newcomer employees and current employees and how they responded in those that had feedback and those who didn't have feedback. And it seemed like on its face that those who had the longest tenure there in that company were the ones who had the highest self-esteem. But the textbook mentions that you can't discount the positive feedback. So both might have had an influence on these individuals, but which one had the most influence? And as you see here on page 256 and 257, that they had discovered that those who had the longest tenure there, the current employees, was the highest tenure there, was the highest influencer. Now, interaction effects. This is differences in dependent variable means due to specific combination of independent variables. So they give you an example here on page 257 that shows a graph about the ones who were new and those who were current, those with no feedback and those who had received feedback. And here's what we want to do. We want to take a look at those lines, and then we want to take a look at the slope of those lines. Now, where you see the new employee, if you're following in your textbook, you'll see that the top line is the new employees, but also on the bottom line, look at the current employees. There's a steeper slope. So you may see that there are some interacting effects there that you would have to look at. Now, when you're designing an experiment to minimize experimental error, you have the first issue, and that's manipulation of the independent variable. You have experimental treatment, and that's the way an experimental variable is manipulated. And then you have categorical and continuous variables, which fall under that. A categorical variable is described by class or quality, male, female, experienced workers, non-experienced workers. Continuous variable, that's by quantity or level, 20 people, 40 people, supervisors, managers, laborers. Those are different levels. So you have those different types of variables that you can study. The experimental group is the group that is being manipulated. You can administer some type of variable in there to see how they respond to it. The control group is the group that has nothing applied to it whatsoever. Now, let's say, for instance, I wanted to look at the attitudes of people or performance of students here at Mid-America, and I wanted to test whether or not students performed better or worse in extreme temperatures. So I would have one group, the control group, that would sit in a classroom, a normal classroom, normal in quantity, which is the continuous variable, but I would also have another classroom across the hall that would have either the same amount or different amounts. But in the first classroom, I would have the temperature set like it's normally set, let's say 70 degrees. So I would keep it at 70 degrees, but on the other group, I would increase it to 90, 85 or 90 degrees. That's the experimental group. These are the ones that I'm introducing a variable to, and I want to see how they respond to that. In contrast to how those who are normally used to the room, how they get along, and that would be my standard. The control group is the standard that you want to measure everything else by. So those who are in 90-degree heat did worse or complained more than those that were in the control group. And I could do the same thing with lowering the temperature. I could have, in the wintertime, cut the temperature off in that room and see how they respond. Really what you're doing is you're testing that experimental group based on different variables and seeing how they perform as opposed to the control group where you're not doing anything to and you're seeing the difference. Now, when it comes to more than one independent variable, you get an idea here of the cell. Now, if you go back to the study that was done in the textbook with the workers, you had the current employees, you had newcomers, you had feedback, and then you had no feedback. All of those are different variables into themselves, and we call those cells. And you see the formula here for being able to calculate or computate the number of cells in an experiment. And we see here K, which represents cell, is equal to the level or number of treatments for condition 1, 2, and so on and so forth. Another example of that would be, if you notice on page 258, they're looking at how investing in marketing would influence the amount of revenue they could generate. And you have 250, 500,000, 750,000, a million. So those would be different treatment levels for experimenting. So that's how you compute that. Repeated measures. These are experiments in which an individual is exposed to more than one level of an experimental treatment. You may put a person, and if we thought the person was the one that was in charge or was responsible for generating more marketing revenue, then we may put that person in, let's say, a region that had $250,000 in its budget, and then the next year we may move that person to an area that invested $1 million. And we would see if there was any difference in the amount of revenue we could generate. That's using that person over and over than just using them once and not being able to use them again. So that's repeated measures. Some of the issues that you need to consider when you're designing an experiment, you need to select variables that are relevant and true for the outcome, and that's true. You want to make sure you are measuring and experimenting with the actual groups or subjects that are pertinent to that study. Choose the right dependent variable, or choosing the right dependent variable is part of the problem definition process. And when you go through the problem definition and the steps to solve problems, you'll see that the most important step is to choose the right dependent variables after you have identified the problem. Here you have the issue of sampling and random sampling. I believe I've talked about that before, but random sampling means that you are testing people on a random basis. You're not cherry picking people because you like them or dislike them or whatever. They are just picked right out of the blue, and that means everybody has an equal shot at being chosen. So that's the major issue when it comes to sampling. You hear randomization. That's the process of selecting people equally without bias. Normally you will have a computer program, or computers will do that to help you gain a better or more accurate and fair selection process and so forth. So that's randomization. You can also look at controlling extraneous variables. Those are the things, again, that can come in and contaminate or influence your experiment without you knowing anything about it. So, for instance, the people that I put in that cold room, they may not have they may not have an issue with cold weather because they come from, let's say, Minnesota, and I didn't know about it, or they came from northern states, or when it was hot, 90 degrees, someone opened the window without me knowing it, and cold air came in. These are extraneous variables that you may not be aware of occurring, but it's going to have an effect on the outcome of your research. Confounds means that there is an alternative explanation beyond the experimental variable for any observed differences in the dependent variable. In other words, what this means is that your research or your experiment may be the result of something else than what you thought it might have been. This, in a way, is what we see a lot of times especially during the political season like we're in now. All of these polls that you see today as far as popularity, 51% of the population disapproves of Donald Trump. Well, if you are looking at predominantly Democratic states, then that's going to be a confound. That's going to be something that will influence the research, and you might not have even realized that you were doing that. Another confound would be what we saw earlier, the categorical variable in the study of the workers and their self-efficacy. Sex, their gender, could have accounted for the reason why the results were like they were. There might have been more men who responded or were part of that experiment than women. And the men were not very emotional, or they're not low in self-esteem. They're fairly confident. That's something, even though you don't realize it or account for it, it could come in and really question the results of your study. That's why usually when you have a research project, that research project is going to be validated by other researchers who will come in and look at the way you did your research, your methodology, your conclusions, and they will sometimes come back and challenge you on that. And extraneous variables, we've already talked about. That's the things that exist in the environment that may have some effect on the dependent variable, but you didn't know or didn't account for it, so it comes out that it's extra that you didn't plan on. Demand characteristics, this is where people are made aware that they're being studied. The control group, they knew that they were going to be studied when I started turning up the heat or whatever, and they start acting in a way that they think you would expect them to act. The Hawthorne effect is probably one of the first cases where that happened, where in Hawthorne, Pennsylvania, they did a study on workers at the General Electric plant, and they studied how workers would act if the good workers were pitted against the less adept, I'll put it that way, the lowest or the lower performing workers. And they pitted them against each other, and they found out that the workers who were the good workers, they slacked off when they realized that they were outperforming the low-performing workers. And one of the things that they learned from that was cohesion and how workers will stick together. But they also discovered that they knew they were being studied, so they acted in a way that they felt they should act instead of how they would have acted if they didn't know anybody was watching them. In establishing control, really you're looking at the constancy of conditions. If you're going to have an experiment, the conditions need to be identical every time, except for the differing experimental treatments. How you apply the variables, they really need to be all consistent. Counterbalancing, and that's the attempt to eliminate the confounding effects of order of presentation by varying the order of presentation or exposure of treatments to subject groups. So if you're not consistent, if you aren't eliminating those areas that will confound this experiment, you're looking at the possibility of your experiment being rendered null and void or invalidated. Ethical issues always communicate. You may not be able to tell them what you're doing, but you need to tell them the purpose and explain the researcher's hypothesis. Now, something as small as changing the temperature or areas where like demand characteristics you want to avoid as much as possible, but you do need to communicate after the fact that they were part of this experiment and this is how it was going to be used, and making sure that they have anonymity, that they won't have their information or their names or anything like that given out. And then you have some of the different ways. You have basic experimentation. You have a single variable, both independent and dependent. You have factorial experimental design. It looks for the investigation of the interaction of two or more independent variables. So they may look at longevity and feedback. Laboratory experiment, as it implies, you're in a controlled setting and you control the variables. And then field experiment, where you go out and you conduct your experiment in the natural environment. And they give you a little picture here, a little insert. It looks like a public place, like a mall or something, where you can experiment with people. Well, today we had a chance to take a look at what experimentation is all about. At least we got through the first part of Chapter 12. There's a lot to it, so we'll continue on next week as we finish up Chapter 12. But until then, understand some of the definitions that we talked about, especially subject, variables, and some of the issues that are involving randomization and the ethics of experimentation. Well, that will do us for right now. You have a good weekend, and we will come back next week and finish up.